Today we're going to talk about the natural logarithm. So we've talked about the natural base before, e, okay, the natural base e, so we're recalling that natural base e, which is actually a number approximately equal to 2.718. Okay, now we're going to talk about the natural log. So let's just recall for any base. We could have a base of 2 and put an exponent on there of anything that we want. But let's put an x there, okay? So we could have 2 to the power of x. Okay, or then with the natural base, we could have e to the power of x, okay? And then we could use those as functions, y equals 2 to the power of x, or y equals e to the power of x. Now, we're going to have the natural logarithm as well. So the base of that logarithm is e. So if we have log base e of some number, okay, let's call it x for now. This is just another number. It's instead of base 2, instead of base 10, instead of base 70, we now have base e, which is a number approximately equal to 2.718. And this is a naturally occurring number that you'll see lots. In fact, the most frequent bases used in logarithms is base 10 and base e. Okay, now, however, there's a shorthand way of writing log base e of x. It's written ln, so ln, okay, of x. Now, this means log base e of x, okay, but this one is the proper notation. So this is the notation that you will see over and over and over representing log base e, okay? Just like if we just see log x by itself, we know that this is base 10. If we see ln e, then we know that that is base e. Okay, so that we've talked about the notation then. Let's talk about the laws of logs. So we have these laws of logs. Log a plus log b equals log ab. Log a subtract log b equals log a divided by b, and n times log a equals log a to the power of n. Okay, 3 log laws. Now these are any bases. We could put any base we wanted. As long as all 3 of these bases are the same, then that statement is true. As long as all 3 of these bases are the same, that statement is true. And same with if both of these are the same base, this is also true. So we could write this for base e. Okay, we could have all of these as base e. So if all of these were base e, these same 3 laws still exist. However, we're going to write them a little differently. We're going to write them as ln a plus ln b equals ln ab. We're going to write ln a subtract ln b equals ln a divided by b, and we're going to write n ln a is equal to ln a to the power of n. But always remember that those are base e, especially if you need to rearrange. Okay, you need to rearrange into an exponent statement in order to solve later on. You'll need to remember that that's base e. Okay, so other log rules. Let's recall again. We have this rule here. Log base a of a to the power of x is actually equal to x. Well, this still applies for ln. So if we have log base e of e to the power of x, that will also be equal to x. In other words, writing it with proper notation, then we would say ln e to the power of x is actually equal to x. Hopefully you can see that there. Can we see it? Yes, we can. Okay, perfect. Okay. Similarly, now we didn't talk about this, I don't think, but here's another little trick or rule that is also true. If we have a to the power of, and this whole exponent is log with another base of x, that whole thing is also going to be equal to x. Okay, so this will also apply to the natural log and the natural base. So if we have e to the power of log base e of x, that is also going to equal x. In other words, written in proper notation, if we have e to the power of ln e to the x that will always, always, always equal x. Okay, so there's some new rules for you. Well, they look new because we're using a new base, but they're the same rules we've looked at as laws of logs and other little rules of logs. There we go.